The field of web development not only teaches you the behind-the-scenes steps of web programming, creating and maintaining website and web application, but it also improves other skills such as critical thinking, communication skills, creativity, and also opens the door to lucrative job opportunities. Good people, before diving deep into the field of web development and programming, learning how the internet and web works is very essential, as it will give you a foundational knowledge of how several technologies work over the internet and the entire web. Not having these fundamentals will impact you negatively as a developer or someone interested to know how internet works. Good people, this course contains 10 different topics arranged systematically like chapters of a book. I will start with the very basic fundamental concept of network. What is network, example of networks, and how does it work the way it does. We'll define what client-server model for communication is and also go further by giving some good example. We look at understanding the OSI reference model and why it is important in internet and web communication. We'll dive into the concept that is of internet protocol. What is internet protocol, why it is important in data communication, and also give example of it. We'll look at categorizing IPv4, what is DNS server, default gateway, and concept of network address translation. Not only that, we will look at various networking services such as DHCP, routing and remote access service, internet protocol security, network time protocol, and voice over internet protocol. Good people, you will also appreciate learning about fundamentals of routing and packet switching in internet communication. We'll introduce you to what is internet, its history in brief, and how do VPNs work, defining what extranet and intranet are, firewalls and other perimeters security devices. We will look at domain names and web hosting in details and also understand their significant differences. We'll teach you what is World Wide Web, how it works, what is website, web server, web browser, and client server model of communication on web. We will also look at internet connectivity and talk of things you have been hearing, such as ISP, that's internet service provider, and common method of internet connection. Good people, last but not least, will provide a general overview of cloud computing, its delivery models, and risk. You will also gain an understanding of how the cloud can support business, research, education, and community infrastructure, and how to get started using the cloud for your own projects. Towards the end of this course, we'll also explain to you what are search engines and how do they work, and also give their examples. Good people, my name is Anwar Mlombi from Mulan Technologies, and I'll be taking you through this complete course of introduction to internet and web fundamentals. So if you have not subscribed to my channel, hit that subscribe button, hit that notification bell icon to get notified whenever I upload a video in the coming days. Leave your comments below in the comment section, and if you find this is the kind of content that you want or you have been looking for, share this video to help your friends know about it. See you in the next video. A computer network can be described as a system of interconnected devices, commonly referred to as nodes, that can communicate using some common set standards or rules called protocols, which are used to transmit information over physical or wireless technologies. These devices communicate to exchange resources and services. These devices are connected to each other using physical media such as copper, fiber optics, or they can also be connected wirelessly. Guys, in this diagram, we can see 4 computers and 1 printer connected to each other using copper wire as a physical medium with the switch as a central connecting device. This is an example of a network, and one of the resources being shared here amongst the 4 computers is the printer. Networks are comprised of 4 basic elements, which are hardware, software and protocols, and the connection media. All data networks are comprised of this element and cannot function without them. The backbone of any network is the hardware that it runs. Network hardware includes things like the network cards, routers or network switches, modems, and Ethernet repeaters. Without these hardwares, computers have no means of accessing a network. Network cards gives computer a direct access to network media and enable them to connect to other equipment, including routers, switches, modems, and repeaters. Routers or switches allow a single network connection from a modem to be divided between several computers. Network software refers to a wide range of software that streamlines the operation, design, monitoring, and implementation of computer networks. The primary form of software protocols that refers to a software which instructs network devices on how to connect to the network and how to interact and communicate with one another. Networking software eliminates the dependency on hardware by streamlining communication across multiple devices, location, and system. Guys, example of a protocol in this component is what referred to as TCP/IP that allows different types of computers to communicate with each other over the network. Another component is what referred to as the client devices or nodes. Client devices are the computers and mobile devices connected to the network. Client devices are a vital component of a network, as without client requiring access to the network, then it's essentially pointless. Connection media refers to the medium used to connect the nodes of a network and varies with the type of network. Connection media, they are categorized into 2 categories, that is wired media and wireless media. What are wired media? Example of wired technologies or media used in network include things such as the coaxial cables, phone lines, twisted pair cabling, and optical fibers. Then with wireless, network connection can also be established through radio or other electromagnetic signals. This kind of transmission is what referred to as wireless. The most common example of wireless links includes communication satellites, cellular network, and radio technology spread spectrums. Computer networks have the following key importances. Number 1, resource sharing. A network allows data and other resources such as files, printers, and media to be accessible to every pertinent user in an organization. You can be able to share files and resources such as printers. Number 2, streamlined communication. Networks are critical for email, instant messaging, and faxing capabilities. For example, employees can share files,
view each other's work, sync their calendars, and exchange ideas more effectively. Number 3, key objective of a network. Network centralize data and make it more accessible, which increases the efficiency and need with which this information can be accessed. Resource availability and reliability. A network ensures that resources are not present in inaccessible silos, are available from multiple points. The last objective of a network is what referred to as the secured remote access. Guys, computer networks promote flexibility, which is important in uncertain times like now, when natural disasters and pandemics are ravaging the world. Give an example of the COVID-19. A secure network ensures that users have a safe way of accessing and working on sensitive data even when they're away from the company premises. Now, after looking at the key objective of a network, I understand there are many. I want us now to understand different type of computer network that we have. Number 1 is what we refer to as the local area network. What is local area network? A local area network is a group of computers that are confined to a small geographical area, usually building. For example, when you look at this figure, the circle, it implies something like a building, and inside that building we are having different computers that are interconnected to each other using switch. So this is an example of a local area network. It can also be in an office. Setting up a LAN or local area network requires computer with network adapters, central connecting devices to connect to those together like the switches, and numbering scheme, which we refer to as the IP addresses to differentiate from one computer to the next. We'll be talking about IP addresses in the subsequent lessons. Usually, LANs utilize one of several Ethernet standards. Ethernet is basically a type of protocol. We talked one of the component of a network, there are software and protocols. So Ethernet is just a set of rules that govern the transmission of data between network adapters and various central connecting devices. Campus area networks are a collection of interconnected LANs. They are used by large entities such as universities and government. Let us look at this diagram. This is an example illustration of campus area network. We see we're having one building that is the hostel, we're having one building that's the college, we're having another building that's the library, and we're having another building that is the lab. They are interconnected to each other over the internet. So this is an illustration that you'll find in most of the university. We have one faculty here, we have another faculty there, we have another faculty in another building. Then they are interconnected to each other over the internet. It's also used in government entities. A metropolitan area network is a computer network that is larger than that in a single building local area network and is located in a single geographical area like a city. Let us take an example of a city. We have different buildings with LANs. So each LANs, like for example in this diagram, each LANs combined together, they form what we refer to as the metropolitan area network. That's MAN. It's confined within, that's like a city, or it can be like a town. It's not in one geographical building, just a single city. Wide area networks cover large areas such as large cities, states, and even countries, and are always established with list telecommunication circuits. Businesses as well as government entities use wide area networks to relay data to staff, students, clients, buyers, and suppliers from various locations around the world. Let us think of a wide area network. Let me give you an example of a bank. A bank has different stations or branches. These branches are not connected to each other locally. They are not connected via local area network. They are connected to each other because they are based in different locations. They are connected to each other with wide area network. Network topology refers to the pattern or hierarchy in which devices or nodes are connected to each other. The organization of these devices that form a network. Topology, they may also be described or describe how data is transferred from one node to another. There are two types of network topology. We have one referred to as the physical topology and the other one called logical topology. Physical topology emphasizes the physical layout of the connected devices and nodes. That physical layout, how computers are organized, that physical layout is what referred to as the physical topology, that pattern. Logical topology, on the other hand, focuses on the pattern of data transfer between network nodes. The physical and logical network topology of a network do not necessarily have to be identical. However, both physical and network topologies can be categorized into three common basic models. Number one, star topology. With star topology, all the nodes in the network are connected to a central device like a hub or a switch via cables. Failure of individual nodes or cables does not necessarily create downtime in the network, but the failure of that central connecting device can. This topology is the most preferred and most popular model. Look at this diagram. That's an example of a star topology. Central connection device, it can be a switch or a hub. The second type of topology is what we refer to as the ring topology. With ring topology, all network devices or nodes are connected sequentially to a backbone, which ends at the starting node, forming a ring. Ring topology shares many bus disadvantages, so it is limited to network that demand high throughput. The last type of most common topology is what referred to as the mesh topology. When we have mesh topology, each node is directly connected to some or other nodes present in the network. This redundancy makes the network highly fault tolerant, but escalated cost may limit this topology to a highly critical network. As we'll be going around interacting with network concept, there are some terminology that will be coming across with an IP address. An IP address is just that unique number that assigned to every device or node connected to a network that uses the internet protocol to communicate to each other. Each IP address identifies the device, host network, and the location of the device on the network. Another type of terminology that you have even had me mentioning is what referred to as a node. A node is basically a connection point inside the network that can receive, send, create, or store data. Each node requires to provide some form of identification to receive access, like an IP address. A few examples of nodes include things such as computers, printers, modems, bridges, and switches. Another type of common terminology you'll hear what referred to as the router. A router is just a physical or virtual device that sends information contained in packets between networks. So it interconnects different networks. So routers will analyze data with the packets to determine the best way for the information to reach its ultimate destination. Another type of common terminology is what referred to as the switches. A switch is just a device that connects other networks and manages node-to-node communication with a network, ensuring the data packets reach their ultimate decision. The Open System Interconnection, abbreviated as OSI reference model, is a conceptual model that helps you understand how data in a networking environment actually works from one computer to another, regardless of where the computer is or what the software it runs. This model is composed of 7 layers, with each corresponding devices, protocols, standards, and application in the real world. Computer network specialists use the OSI model to aid them when designing, maintaining, and troubleshooting computer network. The OSI model was created and ratified by International Organization for Standardization, ISO. What is ISO? It's a non-governmental organization based in Geneva which develops and publishes international standards. It is represented in the US by the American National Standard Institute, ANSI. This OSI model was created to do the following. Number one, explain network communication between hosts on a network. Number two, present a categorization system for communication protocol suites. Lastly, show how different protocol suites can communicate with each other. The OSI model was created as a set of 7 layers, each of which houses different protocols within one of the 7 protocol suites, the most common, which is TCP/IP. The OSI models shows how a protocol stack works on different levels of transmission. That is, how it stacks up together against the model. As mentioned previously, during my topic on computer network, a LAN requires computer with network adapters. This must be connected together in some of the way to facilitate the transfer of data between them. The first layer of the OSI model is what referred to as the physical layer. This is the physical and electrical medium for data transfer. It includes but not limited to cables, jacks, patch panels, and hubs. Concepts related to the physical layer include topologies, analog versus digital encoding, bit synchronization, baseband versus breadband, multiplexing, and serial data transfer. If you touch a network element, it's part of the physical layer, which makes this layer one of the easiest to understand. Then the unit of measurement used in this layer is what we refer to as bits. The second layer of the OSI model is what we refer to as the data link layer. This layer establishes, maintains, and decides how transfer is accomplished over the physical layer. Devices that exist on the data link layer are network interface card, that's NIC, and bridges. This layer also ensures error-free transmission over the physical layer under LAN transmission. It does so through physical addresses, that's the hexadecimal address that is bound into the CD-ROM of the network interface card that we normally refer to as MAC address. The unit of measurement used on this layer is frames. Layer number 3 is what we refer to as the network layer. Network layer is dedicated to routing and switching information to different networks, LANs or internetwork. Guys, we will discuss more about routing and switching in the coming lessons. Devices that exist on the network layers are routers and IP switches. Here, we are getting into the logical addressing of host. Instead of physical addresses, the addressing system of the computer is stored in the operating system. For example, the IP addresses. At this point, you can see that a typical computer will really have two addresses, a physical address such as MAC address and a logical or software-based address such as an IP address. The unit of measurement used in this layer is what we refer to as the packets. And guys, just to let you know, a layer 3 switch differs from a layer 2 switch in that it determines paths for data using logical addressing, that's IP address, instead of the physical addressing, what we refer to as the MAC addresses. Remember, there are two of the OSI model is what we refer to as the data link layer. And we said that data link layer ensures error-free transmission of over the physical layer under LAN transmission, and it does so through physical addressing mechanism that we always refer to as the MAC address. Layer number 4 is what refers to as the transport layer. This layer ensures error-free transmission between hosts through logical addressing. Therefore, it manages the transmission of messages through layer 1 to 3. The protocols that are categorized by this layer break up messages, send them through the subnets, and ensure correct reassembly at the receiving end, making sure that there are no duplicates or lost messages. This layer contains both connection-oriented and connectionless system. Inbound and outbound ports are controlled by this layer. So, guys, when you think of ports, think of the transport layer. The two TCP IP protocols that are utilized in this layer include the transmission control protocol, which is connection-oriented protocol, and the user datagram protocol, UDP, which is connectionless. An example of an application that uses TCP is a web browser, and an example of an application that uses UDP is what referred to as a streaming media like YouTube. So just to break it down, when you download a web page, you don't want to lose any packet of information because graphics will appear broken, certain text wouldn't read correctly, and so on. By using TCP, which is connection oriented, we ensure that data gets to its final destination. If a packet is lost along the way, it will be resent until the destination computer acknowledges delivery or ends the session. But with streaming media, we are either watching or listening in real time. So if a packet is lost, we really don't care because that time frame for the video or music has already passed. The unit of measurement here is what we refer to as segments or sometimes messages. This layer governs the establishment, termination, and synchronization of sessions within the operating system over the network and between hosts. For example, when you log on and log off. This is the layer that controls the name and addresses of database for operating system. Network basic input output, that's NetBIOS, also work on this layer. Layer number 6 of the OSI model is what referred to as the presentation layer. This layer translates the data format from sender to the receiver in various operating systems that may be used. Concepts that include code conversion, data compression, and file encryption are found here. Directors also work on this layer, such as mapped network devices that enable a computer to access file shares on a remote computer. Then, the last layer of the OSI model is what we refer to as the application layer. This layer is where message creation and therefore packet creation begins. Database access is on this layer. End user protocols such as file transfer protocol, symbol mail transfer protocol, telnet, RRAS work at this layer. For example, suppose you are using an Outlook Express. You type a message and click send. This initiates symbol mail transfer protocol and other protocols which send mail messages down through the layers, breaking it into packets and the network layer, and so on. This layer is not the application itself, but the protocol that are initiated by this layer. Although in the earlier lesson, we defined each of the OSI models starting at the bottom, the physical layer, and moving upward there. Quite often, you will see the layers listed from top to down, with the application at the top and the physical layer at the bottom, as shown on this diagram, where we are having a transmitting computer and a receiving computer, and these layers are stuck on each other from top to bottom. That's from application to the physical, not like the other way when we start with the physical to the application. In general, just to break down this document, let us transaction start at the sending computer, travel down to the OSI layers, starting the application layer at the top and ending with the physical layer at the bottom, and are transmitted across the physical medium, be it wired or wireless, and travel back up levels of the OSI model at the receiving computer. For example, if you wanted to connect to our website, you will type the name of the site in your web browser address field. Then you press the enter. The HTTP protocol will take effect at the application layer. The packets of data will be compressed and possibly encrypted, that's HTTPS, by way of SSL or TLS at the presentation layer. The web server acknowledges the session with the client web browser at the session layer. The information will then be transmitted at TCP information on the transport layer, where the ports are also selected. The TCP information will be broken up into easy packets, into easy send packets on the network layer, and an IP address information will be added. The packet will then be sent to the data link layer, where the network adapter will encapsulate them into frames of data. Then at the physical layer, the network adapter will break the frames up into the serial bit stream to be sent over the cable medium. So just to aid you, the figure below, we can just review the OSI layers and show the corresponding devices, protocols, and network standard that apply in each other. Just to give an example, at layer number 7, the application layer, the protocols that you have there, file transfer protocol, they have the HTTP, we have the POP3, we have the SMTP, and the device that is found there. An example is the gateway. Then we go to the presentation layer, concept of compression and encryption. At the session layer, creation of session, that's the log on off and logging on and logging off. We have the transport layer, we have the TCP and UDP protocols. We have the network layer, things such as IP, SMP, address resolution protocol, RIP. Then the device, this layer 3, that's the routers. Then we have the data link layer and the physical layer. So you can take your time, study this table, and it will help you further. Internet protocols are a set of rules that govern the communication and exchange of data over the internet. Both the sender and receiver should follow the same protocols in order to communicate the data. These protocols manage the flow of data, access control of the link being shared in the communication challenge. For example, over the internet, whenever we access a website or exchange some data with another device, this process are governed by a set of rules called the Internet Protocols. Guys, now that we understand that Internet Protocol is just a set of rules, I want us to look at the commonly used Internet protocols that I understand some of us must have interacted with them in one way or another. The first type of Internet protocol is what we refer to as HTTP, an abbreviation for Hypertext Transfer Protocol. This protocol is used to transfer hypertext, that special form of text that contains links to other text, over the internet, and it's defined by the World Wide Web, that's abbreviated as WWW, for information transfer. This protocol defines how the information needs to be formatted and transmitted, and various actions the web browser should take in response to the calls made to access a particular web page. Friends, whenever a user opens their web browser, the user will indirectly use HTTP protocol, as this is the protocol that is being used to share texts, images, and other multimedia files on the World Wide Web. The second type of protocol is what refers TCP IP, that's Transmission Control Protocol, Internet Protocol. And what are they? These are a set of standard rules that allows different computers, that's different types of computers, to communicate with each other. The IP protocol ensures that each computer that is connected to the internet is having a specific serial number called IP address. TCP specifies how data is exchanged over the internet and how it should be broken into IP packets. TCP makes sure that the packets have the information about the source of the message data, the destination of the message data, the sequence in which the message data should be reassembled, and checks if the message has been sent correctly to the specific generation. Another type of internet protocol that we have is what we refer to as the Simple Mail Transfer Protocol, abbreviated as SMTP. This protocol are important for sending and distributing outgoing emails. This protocol uses the header of the email to get the email ID of the receiver and enters the mail into the queue of outgoing mails. And as soon as it delivers the mail to the receiving email ID, it removes the email from the outgoing list. Another type of internet protocol is POP3, that's Post Office Protocol version 3. This protocol helps us to retrieve and manage emails from the mailbox on the receiver mail server to the receiver's computer. The last protocol that I'm looking today is what I refer to as File Transfer Protocol, abbreviated as FTP. This protocol is used for transmitting files or transferring files from one system to the other. This works on a client-server model. When a machine requests for the files from another machine, the FTP sets up a connection between the two and authenticates each other using their ID and password. And the desired file transfer takes place between the machines. So, what is IP version 4 address? An IP address is a unique 32-bit strings of numbers separated by periods assigned to every device connected to a network that uses the Internet Protocol for communication. Each IP address identifies the device host network and the location of the device on the host network. Guys, when device sends data to another, the data includes a header that includes the IP address of the sending device and the IP address of the destination device. So let us look at types of IP version 4 addresses. IP version 4 addresses are further classified as either public or private. Public addresses are ones that are exposed to the internet. Any other computers on the internet can potentially communicate them, while private IP addresses are hidden from the internet and any other networks. They are usually behind an IP proxy or firewall devices. Just to let you know, IP addresses can be allocated manually, which we term them as static IP addresses, or dynamically using a special program called DHCP, that's Dynamic Host Control Protocol, and such kind of IP addresses, we refer to them as dynamic IP addresses. From the previous slide, we see that IP addresses are expressed as a set of 4 numbers in decimal format, and each set is separated by a dot. The IP version 4 address has 2 parts: the network part, which specifies the particular network to where the IP version 4 address belongs, and the host part, which uniquely identifies the device or the interface on your computer. For example, in this IP address, the one that we look at the previous slide, the network portion is represented by 192.168.123, while the host part or the node part is represented by .132. A subnet mask is used to identify these parts. Internet addresses are allocated by the Internet. That's the organization that administers the internet. IP addresses are divided into classes. The most common of them are classes A, B, and C. Classes D and E exist but aren't used by end users. Each of the address classes has a different default subnet mask. You can identify the class of an IP address by looking at its first octet. The subnet mask is used by the TCP/IP protocol to determine whether a host is on the local subnet or on a remote network. Following are the ranges of class A, B, and C IP addresses, each with their default subnet mask, the network/node portion, number of networks, and usable addresses. A class A network uses a default subnet mask of 255.0.0.0 and have a 0 to 127 as their first octet. For example, the address 10.52.36.11 is a class A address. Its first octet is 0, which is between 1 and 126 inclusive. Class B networks use a default subnet mask of 255.255.0.0 and have a 128 to 191 as their first octet. An address such as 172.16.52.63 is a class B address example. Its first octet is 172, which is between 128 and 191 inclusive. Class C network use a default subnet mask of 255.255.255.0 and have a 192 to 223 as their first octet. The address 192.168.123.132 is a class C address. Its first octet is 192, which is between 192 and 223 inclusive. Just to let you know, a Class A network addresses are used by the government, ISPs, big corporations, and large universities. Class B network addresses are used by mid-sized companies and small ISPs. Class C network addresses are used by small offices and home offices. The default gateway is the first IP address of the device that a client computers will look for when attempting to gain access outside the local area network. This device could be a router, firewall, server, or other similar device. It's the device that grants access to the internet or other networks. This device address is on the same network as the client. For example, if the client is 192.168.50.2, the gateway might be 192.168.50.1. The domain name system, abbreviated as DNS, is a naming database in which internet domain names are located and translated into IP addresses. The domain name system maps the name people use to locate a website to the IP address that computer uses to locate that website. For example, if someone types google.com into web browser, a server behind the scenes maps that name to corresponding IP address. An IP address is in similar structure to 203.0.113.72. Therefore, from the definition of domain name system, we can therefore conclude that a DNS server is the server or computer that resolves DNS addresses to IP addresses.
Dynamic Host Control Protocol, that's DHCP, is a client-server network management protocol that automatically assigns an IP address and other related configuration informations such as subnet mask and default gateway to the nodes or devices connected to a network. This technology eliminates the need for individually configuring network devices manually, and it consists of two network components. Number one, a centrally installed network DHCP server and client instances of the protocol stack on each computer or device. Guys, the DHCP server maintains a pool of IP addresses and leases an address to any DHCP enabled client when it starts up on the network. Because the IP addresses are dynamic rather than static, addresses that are no longer in use are automatically returned to the pool for reallocation. When connected to the network and periodically thereafter, a client requests a set of parameters from the server using DHCP. For example, within a local area network, a DHCP server assigns a local IP address to each device. Depending on the implementation, the DHCP server may have three methods for allocating IP addresses. Number one, dynamic allocation, where a network administrator reserves a range of IP addresses for DHCP, and each client on the LAN is configured to request an IP address from the client server during network initialization. Number two is automatic allocation. This is where the DHCP server permanently assigns an IP address to a requesting client from a range defined by an administrator. The server keeps a table of past IP addresses assignments so that it can preferentially assign to a client the same IP address that the client previously had. Then the last method of allocation is manual allocation, where an administrator maps a unique identifier such as MAC address for each client to an IP address, which is offered to the requesting client. DHCP servers may be configured to fall back to other methods if this one failed. Remote access services, abbreviated as RRAS, is grouping of different hardware and software platforms to allow remote access to another computer or network device. Microsoft RRAS has morphed into routing and remote access service, that's RRAS. This powerful service allows clients to connect remotely to a central network using dial-up and high-speed internet connection. RRAS provides a remote user with access to an internal network via a secured private network, that's VPN connection. This connectivity can be deployed using typical IP-based VPN over the internet, or like an internet service provider, that's ISP. It can be deployed through a dial-up services by allowing remote users to connect with organizational network after authentication. RRAS also supports site-to-site connectivity between two different remote servers. Internet Protocol Security, that is IPsec, is a protocol within the TCP/IP suites that encrypts and authenticates IP packets. It's designed to secure any application traffic because it resides on the network layer or the internet layer, as TCP/IP programmers refer to it. This program is used in conjunction with virtual private network and is an integral part of IP version 6. IP packets lack effective security mechanism and may be forged, stolen, or tampered with when being transmitted on a public network such as the internet. To solve this problem, the communicating parties establish an IPsec tunnel for encrypted transmission of IP packets. This ensures secure transmission of IP packets on an insecure network such as the internet. IPsec protects point-to-point communication by establishing secure tunnels between hosts and network security gateways, or between network security gateways such as routers and firewalls. It operates at the IP layer to encrypt and authenticate data packets. Compared with other VPN technologies, IPsec VPN is more secure because its data is encrypted in transmission tunnel. However, the configuration and network deployment of IPsec VPN are more complex. Then, Network Time Protocol, that's NTP, is a protocol that allows the synchronization of system clocks, that's from desktop to servers. Having synchronized clocks is not only convenient but required for many distributed applications. Accurate time for all devices on a computer network is important for many reasons. A discrepancy of even a fraction of a second can cause problems. The last service is what is called Voice over Internet Protocol, that's VoIP. This is a technology that allows you to make voice calls using broadband internet connection instead of a regular or analog phone line. Some VoIP services may only allow you to call other people using same services, but others may allow you to call anyone who has a telephone number, including local, long distance, mobile, and international numbers. VoIP services convert your voice into a digital signal that travels over the internet. If you are calling a regular phone number, the signal is converted to a regular telephone signal before it reaches the destination. Routing is the process of moving data across different networks or internetworks between hosts. Information is transmitted according to the IP networks and individual IP addresses of the host in question. Guys, a router is a device that connects two or more networks. It serves two primary functions. Number one, that's managing traffic between these networks by forwarding data packets to their intended IP address. Number two, allowing multiple devices to use the same internet connection by maintaining tables of information about other routers on the network or inter-network. In this diagram, we can be able to see one router that connects two different LANs and it's able to relay data from one LAN network to another, the process that I call routing. Routing process works by choosing the best path for data packets to take across a network when traveling from one computer to another. The routing process usually directs forwarding on the basis of routing tables. Routing tables maintain just a record of routes to various network destinations. Routing tables may be specified by an administrator, learned by observing network traffic, or built with the assistance of routing protocol. The process of routing undergoes through these 5 steps that have broken them down. Step number 1, computer sends a data packets to a router. It attaches an IP address to packets, just like you put an address label on a physical parcel you want to send. Routers use these addresses to work out the best routes. The origin computer usually connects to a local area network, that's LAN, while the routers send packets from a LAN to another large network. Step number 2, routers will receive the packet and read its IP address. Comparing this to the internal, that's routing table, routers are able to establish which is the best route via the packet, which packet should go. Step number 3, router uses the information to work out the next best network to help the packet to take the next hop closer to its destination. The final hop count is a number of times a packet hops until it reaches the target. When the packet reaches a new network, a whole new router decides the next best hop for it to take. Because of this, routes that packets take are rarely direct. However, thanks to the routing protocols, they are faster and efficient. Last step, the final router sends the data packets to the destination computer. When the data packet finally reaches a router in the same network as the destination address, it can route it directly to the device or server it was sent to. So what does this look like in practice? For instance, when you send an email from a laptop connected to your office LAN, your LAN router receives instructions about the destination IP address. At this point, the email IP packets reach the edge of your LAN network. Here, your LAN router decides the route the email should take based on its routing table, sending it to the next network on its path. Because it's unlikely that your LAN network directly connect to the destination network, the data packets will encounter different routers on their route in the internet. These other routers check the destination IP address of data packets passing their way and they route them accordingly. Eventually, the email reaches a router connected to the server hosting your recipient's email, which routes it to its final destination. Then packet switching is a digital connectionless network transmission process in which data is broken into suitably sized pieces or blocks called packets for fast and efficient transfer via different network devices. See the diagram below for the illustration where data from the sending computer is broken down into several packets while on transit before reaching its destination. That's the receiving computer. Guys, for example, when a computer attempts to send a file to another computer, the file is broken into packets so that it can be sent across the network in the most efficient way. These packets are then routed by a network device to the destination. Internet is a worldwide system of connected computer networks. Computers that connect to the internet use the TCP/IP protocol suite. In our previous lesson, we learned that TCP/IP are a set of standard rules that allow different types of computers to communicate with each other over the internet. Guys, with the internet, it's possible to access almost any information, communicate with anyone else in the world, and do much more. And before we continue, it's good we look at a brief history of internet. On October 29th, that's 1969, an organization called ARPANET, that's Advanced Research Projects Agency, launched the first iteration of the internet, also known as the ARPANET, connecting 4 computers amongst those universities. When this network of computers was connected, universities were able to access files and transmit information from one university to the other, as well as internally. Guys, as researchers developed the system, they continued to connect computers from other universities too. Eventually, ARPANET was renamed to Internet. TCP/IP protocol was established in the year 1970s, allowing internet technology to mature. The development of these protocols aided in the standardization of how data was sent and received via the internet. Just to let you know, the internet has been able to diversify and grow swiftly. Wi-Fi was first introduced in the 1997. The year is 1998 and Windows 98 is released. Smartphone became widespread in 2007 and the 4G network was launched in 2009. The internet is used by approximately 3 billion people nowadays. By the year 2030, there are expected to be 7.5 billion internet users with more than 500 billion devices connected to the internet. Then, how now does the internet works? We have learned from our previous topics that internet is a worldwide computer network that transmits a variety of data and media across interconnected devices. It works by using a packet routing network that follows TCP/IP protocols which work together to ensure that data transmissions across the internet is consistent and reliable no matter which device you are using or where you are using it. When data is transferred over the internet, it's delivered in messages and packets. Data sent over the internet is called messages. But before messages get sent, they are broken up into tiny parts called the packets. These messages and packets travel from one source to the next. Using a numerical address referred to as the IP address, the IP system receives further instruction on how the data should be transferred. The Internet Protocol, that's TCP, works with the IP to ensure transfer of data is dependable and reliable. This helps to make sure that no packets are lost, packets are reassembled in proper sequence, and there is no delay negatively affecting the data quality. For example, when you type a web address in a browser, your PC or device is connected to the web through a modem or a router. Together, these devices allow you to connect to other networks around the globe. Your router enables multiple computers to join the same network, while a modem connects to your ISP, that's Internet Service Provider, which provides you with either cable or DSL internet. Looking at this in practice, in step number 1, you type in a web address known as URL, e.g. www.google.com. Each website has its own unique URL that signals to your ISP where you want to go to. In step number 2, your query is pushed to your ISP, which connects to several servers which store and sends data like a DNS, that's domain name server. In step number 3, your browser looks up the IP address for the domain name you typed into your search engine through DNS. DNS then translates the text-based domain name you typed into the browser into the number-based IP address. Example, google.com is translated to 64.233.191.255. Your browser then sends a HTTP request to the target server to send a copy of the website to the client using TCP/IP. In step number 5, the server then approves the request and sends a 200, that's okay, HTTP request message to your computer. The server sends a website files to the browser in the form of data packets. As your browser reassembles the data packets, the website loads, allowing you to learn, to shop, to browse, and to do any form of browsing. Example of the uses of internet include things such as the email, that's the web chat, World Wide Web, internet telephony, and video conferencing, which refers to the use of voice and images to communicate amongst users. Then sometimes we're going to look under the internet as are what referred to as the intranets and extranets. They are used by organizations to share data with the select individuals, whereas an intranet is used by organization to share data with its employees. An extranet is used to share data with the sister companies or other partnered organizations. Just by definition, an intranet is a private computer network or a single website that an organization implements in order to share data with employees around that's the world. User authentication is necessary before a person can access information in an intranet. Ideally, this keeps the general public out as long as the intranet is properly secured. Guys, generally, a company refers to intranet as its private website, or perhaps the portion of the company website that is private. However, intranets use
all the inherent technologies characteristics of the internet. Then an extranet, on the other hand, is similar to an intranet, except that it's extended to users outside a company and possibly to the entire organization that are separate from a lateral to the company. For instance, if a company often needs to do business with a specific organization, it might choose to set up an extranet in order to facilitate information sharing. User authentication is still necessary, and an extranet is not open to the general public. Then the figure below illustrates both an intranet and extranet. Users can connect to the intranets and extranet by simply logging into a website or by using a virtual private network. Then I want us to look at VPN. What's a VPN? A VPN is a virtual private network that allows connectivity between two remote computers that are not part of the same private network. VPNs encrypt your internet traffic and disguise your online identity. This makes it more difficult for third parties to track your activities online and steal data. The encryption takes place, that is, in real time. In order to ensure that that only the proper users and data session cross to a VPN device, data encapsulation and encryption are used. A tunnel is created, so to speak, through the LANs and WANs that might intervene. This tunnel connects the two VPN devices. Every time a new session is initiated, a new tunnel is created. Some technicians refer to this as tunneling through the internet, although some VPN tunnels might go through private network as well. Then guys, an illustration of a basic VPN is shown on the figure below. Note that the VPN server is on one side of the cloud and the VPN client on the other side. The VPN client will have a standard IP address to connect to its own LAN. The IP address shown in the figure is the IP address it gets from the VPN server. The computer has two IP addresses. In essence, the VPN address is encapsulated within the logical IP address. Then, how does the VPN works? A VPN hides your IP address by letting the network redirect it through a specially configured remote server run by a VPN host. This means that if you surf online with a VPN, the VPN server becomes the source of your data. This means your internet service provider and other third parties cannot see which website you visit or what data you send and receive online. A VPN works like a filter that turns all your data into gibberish. Even if someone were to get their hands on your data, it will be useless. Guys, we are going to look at three types of VPNs with their example. Type number one is what we call remote access VPNs, or the client to server VPN. A remote access VPNs lets you use the internet to connect to a private network such as your company's office network. The internet is an untrusted link in the communication. VPN encryption is used to keep the data private and secure as it travels to and from the private network. To use a remote VPN on your device, you typically need to install client software or configure your device operating system to connect to the VPN. There also need to be a VPN server on the network end of the connection. Example, somebody working from home could use a remote access VPN to access
the company's network from home. Their computers works as if it was connected to the company network in the office, and data is protected as it goes through the public internet. Then the second type of VPN is what we call that's mobile VPN. While remote access VPNs let you connect to a local network from anywhere, they do assume that the user will stay in one location. If the user disconnects, the IP tunnel also closes. With a mobile VPN, is a better option than a remote access VPN if the user is unlikely to have a stable internet connection on the same network for the entire session. With a mobile VPN, the VPN connection persists even if the user switches Wi-Fi or cellular network or loses connectivity or switches the device off for a while. A good example is professionals working from home in an area with poor connectivity could use a mobile VPN to maintain VPN access to the office all day, even when the connection is lost. Then the third type of VPN is the site-to-site VPNs, whereas a remote access VPN is designed to let individual users connect to a network and use its resources. A site-to-site VPN joins together two networks on different sites. For example, if a company had two offices on the East Coast and West Coast, for example, that's a site-to-site VPN could be used to combine them into a single network. Site-to-site VPNs, therefore, enable organizations to combine their networks from different locations into a single network called the intranet. Then about VPN, common technology that's used in site-to-site VPN is IPsec, which we covered in the previous topic when we talked about networking services. Just to let you know, site-to-site VPN can be implemented by use of that's IPsec tunneling or MPLS technology. Multi-protocol label switch, that's MPLS VPNs, can provide a guaranteed quality of service with global connectivity. This is because MPLS is a way of routing packets across a network via any transport medium such as the fiber, satellites, or microwave, and any other protocol. Today, we are looking at World Wide Web. The World Wide Web, commonly referred to as WW or just the web, is an interconnected system of public web pages accessed through the internet. These web pages and documents are interconnected by means of hyperlinks that users click on for information. This information can be in different formats, which includes text, images, audio, and video. Then the components that make up World Wide Web include, number one, that's Hypertext Transfer Protocol, that's HTTP. This protocol is used to transfer hypertext, that special format of text that can contain links to other text over the internet, and it's defined by the www for information transfer. This protocol defines how information needs to be formatted and transmitted, and the various actions on the web browser should take in response to calls made to access a particular web page. Guys, whenever a user opens their web browser, a user will indirectly use the HTTP, as this is the protocol that is being used to share text, images, and other multimedia files on the World Wide Web. HTTP therefore enables users to access web pages by standardizing communication and transfer between internet servers and clients. Then the second component of the web is Uniform Resource Locator, that's URL. A URL is a unique identifier used to locate resource on the internet. Such resource can be things like the HTML page, the CSS document, and image. Here is an example of the URL, that's https developer.mozilla.org. A URL is composed of different parts. Some parts are mandatory and others are optional. The most important parts are highlighted on the URL in the diagram below. The first part of any URL is scheme, which indicates the protocol that the browser must use to request the resource. We learned that a protocol is just a set of methods for exchanging or transferring data around a computer network. Usually, for websites, the protocol is HTTPS or HTTP, which is unsecured. Addressing web pages require one of these two, but browsers also know how to handle other schemes such as mail to, that's to open an email client. So don't be surprised if you see such other protocols. The second part of a URL is authority, which is separated from the scheme by the character pattern. If present, the authority includes both the domain, that's e.g. www.example.com, and the port, that's 80, separated by a colon. The domain indicates which web server is being requested. Then the port indicates the technical get, that's in quotes used to access the resources on the web server. It's usually omitted if the web server uses the standard ports of HTTP protocol, which is 80 for HTTP and 443 for HTTPS, to grant access to resources. Otherwise, it is mandatory. The third part of a URL is path to the resource of the web server. In the early days of the web, a path like this represented a physical file location on the web server, but nowadays it's mostly an abstraction handled by web server without any physical reality. Then the last part of a URL, parameters. There are a list of key value pairs separated with the and simple. The web server can use this parameter to do extra stuff before returning the resource. The third component is the hypertext markup language, that's HTML. HTML is the standard markup language for documents designed to be displayed in a web browser. It can be assisted by technologies such as cascading style sheets, that's CSS, and scripting languages like JavaScript. Guys, HTML describes the structure of web pages using elements or tags and displays the content of these pages through a web browser. In the diagram below shows a simple structure of the HTML document. We will cover more about HTML in the subsequent lesson. Then component number 4 of the World Wide Web is the hyperlink. Hyperlink is an electronic link providing direct access from one distinctly marked place in a hypertext or a hypermedia document to another in the same or different document. This example below show how to create a link to wschools.com. Just look at that structure, and this is a good example of a hyperlink. Guys, we have looked and understood now what is the World Wide Web. I want us to get the difference between the www or the web and the internet. Though the World Wide Web is a big part of the internet, it's not the entire internet. The World Wide Web is just one of the many applications built on top of the internet, a vast global network of multiple smaller networks, while the internet is the entire data communication system that connects the world, including hardware and software. Good people, World Wide Web is an enormous system of interlinked hypertext documents that can be accessed with a web browser. It's therefore a communication model or a platform that enables the retrieval or exchange of information over the internet, that's through HTTP. Through web, users can access web pages over the internet by following a series of HTTP links. Just to let you know, both the internet and the web operate within a client-server model. A server is basically a program that accepts requests from other computers, known as clients on the network, to store and transmit documents. Clients will request documents from a server when a user asks for them, and then displays them on the user's screen. Then, out of all this, how does the web work? For example, when you enter something like google.com on the request, the request goes to one of the many special computers on the internet known as domain name server that we looked in at the beginning of this lecture. The domain name server keeps tables of machine names and the IP addresses. So when you type in google.com, it gets translated into a number which identifies the computers that serve the Google website to you. So when you want to view any page on the web, you must initiate the activity by requesting a page using a browser. The browser asks a domain name server to translate the domain name you requested into an IP address. The browser then sends a request to that server for the page you want using a standard protocol, that's Hypertext Transfer Protocol or HTTP. The server should constantly be connected to the internet, ready to serve pages to visitors. When it receives a request, it looks for the requested document and returns it to the web browser. When a request is made, the server usually logs the client's IP address, the document requested, and the date and time it was requested. This information varies from server to server. These are examples of terminologies you'll always be interacting while using the web. A web client refers to the web browser on the user's computer or mobile device. Then a web browser is a software program that searches for, retrieves, and presentation material, which include web pages, photos, videos, and different files. The browser sends a request to the web server, which then transmits the statistics returned to the browser, which presentation the findings at the laptop. Examples of web browser are Mozilla Firefox and Google Chrome. Then another terminology is a web page. A web page is a document which can be displayed on a web browser such as Firefox or Google Chrome. A web page is generally a segment of an internet site that carries statistics in plenty of formats, which include textual content inside the shape of paragraph, that's list, tables, and so on. A website is a group of web pages connected collectively through links and saved on an internet server. By clicking on a link, a tourist can pass from one page to the next. Then, a web server is a computer hosting one or more websites, Hosting in this case means all the web pages and their supporting files are available on that particular computer. The web server will send any web page from the website it's hosting to a user's browser per user request. Then the last terminology, search engine, is a special kind of website that helps user find web pages from other websites and shows a listing of result. Example is Google, Bing, and Yahoo. We will cover more about the search engines in our last topic in this series. Our question for today's video is, what is domain name? To answer this question, a domain name is an easy to remember address name of your website that people type in the web browser's URL section in order to visit your website over the web or internet. It's the unique name that appears after the @ symbol in email address and after the www in web addresses. For example, the email address mlombi@mulan.co.ke and the web address www.mulan.co.ke both have the domain name as mulan.co.ke. Domain names are translated into special IP addresses by the help of the domain name system. For instance, the domain name google.com might translate to the IP address that's 64.233.191.255. Using domain name to identify a location on the internet rather than numeric IP address make it much easier to remember and type the web address. Then, how do you get a domain name for your website? Guys, anyone can buy a domain name. The most straightforward way to do so is to visit a domain name registrar such as A2, GoDaddy, or Namecheap. Key in the domain name you want to buy and pay a fee. A domain name registrar is basically a business that handles the reservation of domain names as well as the assignment of IP addresses to those domain names. Since we are looking at both the domain name and web hosting, our second question is, what is web hosting? A web hosting service is a type of internet service that hosts website for client. That is, it offers the facilities required for them to create and maintain sites and makes it accessible on the World Wide Web. It is like the home of your website where it actually lives. Companies providing web hosting services are sometimes called web hosts. Examples of web hosting companies include Hostinka, DreamHost, A2 Hosting, HostGator, Bluehost, InMotion, and SiteGround. Then, we should also understand the types of web hosting. There are 4 types of web hosting, which are shared hosting, VPS or virtual private server hosting, dedicated hosting, and cloud hosting. By definition, shared hosting, as the name implies, websites using shared hosting will be sharing resources with other websites on a single server. This works well because the vast majority of websites don't need a whole server of their own. Shared hosting is the most basic type of web hosting. It's cost-effective and best choice for small or entry-level websites. As such, each website on the server will have a limited amount of resources as defined by their specific hosting plan. Good people, think of it as renting an apartment with roommates. You have your own bedroom, but you and your roommates will share resources like water, electricity, and common spaces throughout the house. The nature of sharing a server with other websites has its own drawbacks. For example, if another website on your server has a traffic spike, it can potentially cause performance issues with your site. These situations are out of your control. Virtual private server hosting or VPS hosting. With virtual private server, your website will still be sharing a single server with other websites. However, the number of websites you will be sharing with it is significantly lower. The main server is split into multiple virtual servers, hence the name. These virtual servers can be customized by individual websites. Guys, your site will perform better due to having more resources. This means you will benefit from faster loading times and higher uptimes. You won't have to worry about another website causing your site to crash. A virtual private server is like renting an apartment on your own. You won't be sharing kitchen, bathroom, living room, or other common spaces with any roommate. This gives you much more freedom and flexibility to do what you want with the space. However, you will be sharing some resources with the other units in the building, so there will be some limitation. Hosting type number 3 is dedicated hosting. Dedicated servers are typically considered the best choice in web hosting. That's because you have a dedicated server that belongs to you and you alone. You typically get more benefits with dedicated hosting, too, such as more uptime and faster speeds. However, it comes with catch. This is the most expensive type of web hosting. Since you won't be sharing resources or anything else with the other website, your site will operate at peak performance. A dedicated server is like owning a house. If you want to build a fence, plant a tree in the yard, or a patio, or renovate the kitchen, everything is completely up to you. Then the last type of hosting type is cloud hosting. Cloud hosting employs a virtual server to host website. In comparison, traditional web hosting services usually house one or more sites on one physical server. That's cloud hosting works through virtualization. It's a technology that splits a physical server into multiple virtual machines called cloud servers. Then this connects to create a single network for hosting a website. With the cloud servers, your website will have much high uptime rates and won't have as much unexpected downtime due to server errors. Your site will remain fluid and perform at a higher level. All this said, how do domain names and web hosting related? Domain names and web hosting are two different services, but they work together to make websites possible. But how? Basically, a domain name system is like a massive address book that is constantly updated. Behind each domain name, there is an address of the web hosting services storing the website's files. Without domain names, it will not be possible for people to find your website, and without web hosting, you cannot build a website. This is the question we are asking ourselves today. What is it that is needed to connect to the internet? To answer that question, there are 4 basic ingredients needed to access the internet. Number 1 is a computer, an ISP, a modem, and the last one is a web browser. Good people, by definition, a computer is a programmable electronic device that accepts, raw data as input and processes it with a set of instructions to produce the result as output. It renders outputs just as performing mathematical and logical operations and can save the output for future use. By definition, a modem is an electronic device that converts data to a signal so it can be easily sent and received over a phone line, cable, or satellite communication. For transmission over an analog telephone line, which was once the most popular way to access the internet, the modem converts data between analog and digital formats in real time for two-way network communication. Today, cable and telephone companies provide service to most people, and the modem converts their signals to the internet packets your computer requires. Good people, by definition, a web browser is a software program that searches for and retrieves materials on the internet, which include web pages, photos, videos, and different files. The browser sends a request to the web server, which then transmits the requested data to the browser as HTML page. Mozilla Firefox, Microsoft Edge, and Google Chrome are good examples of internet browsers. Good people, by definition, an ISP, that's Internet Service Provider, is a company that provides individuals and organizations access to the internet and other related services. An ISP has the equipment and the telecommunication line access required to have a point of presence on the internet for the geographic area covered. Just to let you know, ISPs are connected to one or more high-speed internet lines. Larger ISPs have their own high-speed list lines, so they are less dependent on telecommunication services and can provide a better service to their customers. ISP provide transport of internet traffic on behalf of other ISPs, companies, or other non-ISP organizations and individuals. To let you know, ISPs are classified into three-tier model that categorize them based on the type of internet service they provide. ISP are grouped into the following three tiers. Tier number 1, internet service providers are the networks that are the backbone of the internet. These groups of tiers are sometimes referred to as the backbone internet providers. These ISPs build infrastructures as the Atlantic Internet Sea cables. They provide traffic to all other ISPs, not end users. Key Tier 1 ISP include Verizon, Sprint, Singtel, Telstra, Deutsche Telekom, and British Telecom. With a Tier 2 ISP is a service provider that utilizes a combination of paid transit via Tier 1 ISP and pairing with other Tier 2 ISP to deliver internet traffic to end users through Tier 3 ISP. Tier 2 ISP are typical regional or national providers. Only a few Tier 2 ISPs can provide service to customers on more than 2 continents. Often, they will have slower access speeds than Tier 1 ISP and have at least one router hop away from the backbone of the internet. With Tier 3 ISP is a provider that strictly purchases internet transit. A Tier 3 provider is by definition primarily engaged in delivering internet access to end customer. Tier 3 ISPs focus on local business and consumer market condition. They provide the local access to the internet for end customers through cables, DSL, fiber, or wireless access. Their coverage is limited to specific countries or sub-regions such as metro area. Tier 3 ISP utilize and pay higher tier 1 ISP for access to rest of the internet. Good people, what are the common methods of internet connection? Just to answer this question, the type of internet service you choose will largely depend on which type of internet service provider serves your area alongside which type of service they offer. Here are some common methods of internet connection. Number one is DSL. What is DSL? This is digital subscriber line that connects user to the internet using a telephone line. DSL service runs over traditional hardwired phone lines along with or instead of voice communications, and becomes available only in location close enough to phone company equipment setups. It is widely available, but is slowly being replaced by more reliable broadband connections such as cable and fiber. DSL is lower and offers a download speed of 55 to 35 Mbps and upload speed of between 1 to 10 Mbps. It is good options for users in rural areas and those who mainly surf the web or stream TV on one device. Number two is cable. This service uses coaxial cable, same coaxial wiring that carries TV signal. Cable internet has low latency, which is good for users who need less delay or lag time. Cable has download speed of 10 to 500 Mbps and upload speed of between 5 to 50 Mbps. Because cable TV provides a large residential entertainment option, businesses located in office, parks, and other areas away from residential neighborhoods may lack access to cable broadband. In addition, the service speed can drop if local demand causes congestion. Then number three is satellite services. Satellite internet access works through the use of communication satellites. Ground stations relay internet data as radio waves to and from satellites that are likely in low Earth orbits and to further ground stations. Satellite is lower with download speed of between 12 to 100 Mbps and upload speed of 3 Mbps, but it's good option for users in remote areas. Satellite services can provide broadband internet access in rural or outlying areas unreached by wired phone lines or cable connection, similar to satellite TV service but running on different antennas and receiving computer equipment. This broadband options requires an unobstructed aiming path between a small dish and the orbiting satellite. Wiring connects to the antenna modem device, then connects to your computer. The last is fiber internet. Fiber internet uses fiber optic cable to transmit data to provide much faster speeds compared with cable or digital subscriber line, that's DSL. Fiber has a download speed of 250 to 1000 Mbps and an upload speed of 250 to 1000 Mbps. The technology uses fiber optic cable, which amazingly can send data as fast as 70% of the speed of light. In addition, fiber optic cables are not susceptible to severe weather or conditions, other types of traditional cables, which helps minimize outages. It also resists electromagnetic interference effectively. The impact of cloud computing on industry and end users will be difficult to overstate, as many aspects of everyday life have indeed been transformed by the omnipresence of software that runs on cloud networks. By leveraging cloud computing, startups and businesses are able to optimize cost and increase their offerings without purchasing and managing the hardware and software themselves. In today's video, what exactly is cloud computing? In a nutshell, cloud computing is the delivery of computing resources as a service, meaning that the resources are owned and managed by the cloud provider rather than the end user. Those resources may include anything from browser-based applications such as Netflix, third-party data, storage for photos, and other digital medias such as the iCloud or Dropbox, or third-party servers used to support the computing infrastructure of a business, research, or other personal project. Guys, before broad proliferation of cloud computing, businesses and general computer users typically had to buy and maintain the software and hardware that they wished to use. With the growing availability of cloud-based applications, storage services, and machines, businesses and other consumers now have access to wealth of on-demand computing resources as internet-accessed services. Then, shifting from on-premise software and hardware to networked, remote, and distributed resources means that cloud users no longer have to invest the labor, capital, or expertise required for buying and maintaining these computing resources by themselves. This unprecedented access to the computing resources has given rise to new waves of cloud-based businesses, changed IT practices across all industries, and transformed many everyday computer-assisted practices. All this said, the following are essential characteristics of cloud computing. Essential characteristic number one is on-demand self-service. Cloud resources can be accessed or provisioned without human interaction. Note that. With this model, consumers can gain immediate access to cloud services upon a sign-up. Organizations can also create mechanisms for allowing their employees, customers, or partners to access internal cloud services on demand according to predetermined logics without needing to go to or to go through IT services. Number two, broad network access. Users can access cloud provide services and resources through any device and in any networked location, provided they have permission. Essential characteristic number three, resource pooling. Here, cloud provider resources are shared by multiple tenants while keeping the data of individual clients hidden from other clients. Essential characteristic number four is rapid elasticity. Unlike on-premise hardware and software, cloud computing resources can be rapidly increased, decreased, or otherwise modified based on the cloud users' changing needs. Then the last essential characteristic is measured service. Usage of cloud resources is metered so that businesses and other cloud users need only to pay for the resources they use in any given billing cycle. Good people, cloud resources are provided in a variety of different delivery models that offer customers different level of support and flexibility. Delivery model number one is what we term infrastructure as a service. This is the on-demand delivery of computing infrastructures, including operating systems, networking, storage, and other infrastructural components, acting much like a virtual equivalent to physical servers. It relieves cloud users of the need to buy and maintain physical servers, while also providing the flexibility to scale and pay for resources as needed. It's a popular option for businesses that wish to leverage the advantages of the cloud and have system administrators who can oversee the installation, configuration, and management of operating systems, development tools, and other underlying infrastructures that they wish to use. Given its flexibility, infrastructure as a service can support everything from companies' computing infrastructure to web hosting to big data analysis. Number 2 is Platform as a Service, PaaS. Platform as a Service provides a computing platform where the underlying infrastructure, such as the operating systems and other software, is installed, configured, and maintained by the cloud provider, allowing users to focus their efforts on developing and deploying apps in a tested and standardized environment. This is commonly used by software developers and other developer teams, as it cuts down on the flexibility of setting up and maintaining computer infrastructure, while also supporting collaboration among distributed teams. Platform as a Service can be a good choice for developers who don't have the need to customize their underlying infrastructure, or those who want to focus their attention on development rather than DevOps and systems administrator. Number 3 is Software as a Service, that SaaS. Software as a Service providers are cloud-based applications that users access on demand from the internet without needing to install or maintain the software. Example includes GitHub, Google Docs, Slack, and Adobe Creative Cloud. Software as a Service applications are popular among businesses and several users, given that they are often easy to adopt, accessible from any device, and have free, premium, and enterprise versions of the application. Like Platform as a Service, it abstracts away the underlying infrastructure of the software application so that users are only exposed to the interface they can interact with. What are the cloud environments? Cloud services are available as public, private resources, each of which serves different needs. So, what are the public cloud? The public cloud refers to the cloud service such as virtual machines, storage, or application offered publicly by a commercial provider to businesses and individuals. Public cloud resources are hosted on the commercial provider's hardwares, which users access through the internet. Guys, they are not always suitable for organization in highly regulated industries such as healthcare or finance, as public environments may not comply with industry regulations regarding customer data. Then, private cloud refers to the cloud services that are owned and managed by the organization that uses them and available only to the organization's employees and customers. Private clouds allow organizations to exert greater control over their computing environment and their stored data, which can be necessary for organizations in highly regulated industries. Private clouds are sometimes seen as more secure than public clouds, as they are accessed through private networks and enable the organization to directly oversee their cloud security. Public cloud providers sometimes provide their services as applications that can be installed on private clouds, allowing organizations to keep the infrastructures and data on premise while taking advantage of the public cloud's latest environments. Then the last environment is hybrid and multi-cloud. Many organizations use a hybrid cloud environments which combine public and private clouds resources to support the organization's computing needs while maintaining compliance with industry regulation. Multi-cloud environments are also common, which entail the use of more than one public cloud providers. For example, combining Amazon Web Services and DigitalOcean. The following are benefits of cloud computing. Cloud computing, as we have seen, offers a variety of benefits to individuals, businesses, developers, and other organizations. Guys, these benefits vary according to the cloud user's goals and activities. I will begin with business and industries. Prior to the proliferation of cloud computing, most businesses and organizations needed to purchase and maintain the software and hardware that supported their computing activities. As cloud computing resources became available, many businesses began using them to store data, provide enterprise software, and deploy online products and services. Some of these cloud-based adoptions and innovation are industry-specific. In healthcare, many providers use cloud services that are specifically designed to store and share patient data or communicate with patients. In academia, educators and researchers use cloud-based teaching research apps, but there are also a large number of general cloud-based tools that have been adopted across industries, such as apps for productivity, messaging, expense management, video conferencing, project management, newsletters, surveys, customer relations management, identity management, and scheduling. The rapid growth of cloud-based business apps and infrastructure show that cloud is not just changing business IT strategy, it's a booming business in its own right. Then for developers, computing resources that were once only affordable to large companies and organizations are now available on demand through an internet connection and at a fraction of their previous cost. In effect, independent developers can rapidly deploy and experiment with cloud-based apps. Cloud-based apps for sharing codes such as GitHub have also made it easier for developers to build upon and collaborate an open source software project. Additionally, cloud-based educational platforms and interactive coding tutorials have expanded access to developer education, enabling individuals without formal technical training to learn to code in their own. Then for the researchers, as machine learning methods become increasingly important in scientific research, cloud computing has become essential to many scientific fields, including astronomy, physics, genomics, and artificial intelligence. The massive amount of data collected and analyzed in the machine learning and other data-intensive research projects often require cloud computing resources that scale beyond the capacity of hardware owned by an individual researcher or provisioned by the university. Cloud computing allows the researchers to access computing resources such as their workloads requires and allows for real-time collaboration with the research partners across the globe. Without commercial cloud providers, a majority of academic machine learning research would be limited to individuals with access to university provisioned high-powered computing resources. Then for educators and students, guys, you can be able to see that cloud computing has also provided students with tools for supplementing their education and opportunities to put their technical skills into practice as they learn. Cloud-based apps for sharing, teaching, collaborating on code and data such as GitHub enable students to learn technical skills in a hands-on manner by studying, deploying, and contributing to open source software and research projects relevant to their field or professional aspiration. And just like independent developers, students are able to use cloud computing resources to share their codes and apps without the public and reap the satisfactions of underlying the real-world application of their skills. Good people, though the cloud offers many benefits, it also comes with its own set of risks, cost, and ethical questions that should be considered. Some of these issues are relevant to all cloud users, while others are more applicable to businesses and organizations that use the cloud to store customers' data. The following are considerations for all cloud users. Point number 1 is security. Cloud resources can have additional security vulnerabilities compared to traditional on-premise data centers, given their use of APIs, cloud-based credentials, and on-demand services that make it easier for attackers to obtain unauthorized access. Find out what measures the cloud provider service takes to secure customer data from theft and other attacks, and what are practices or additional services customers can implement to safeguard their personal data. Number 2 is data loss. Just with the physical owned or managed devices, cloud services can permanently lose stored data due to physical disaster, bugs, unattended syncing, user-generated errors, or other unforeseen issues. When implementing cloud services, find out what backup service the provider offers to be aware that this may not be automatically or fully provided. You may also choose to run backups yourself. Consideration number 3, data persistence. There are times when cloud users may want to ensure the deletion of personal data they have given to cloud service provider. However, the processes for deleting data on cloud resources and verifying that deletion can be time-consuming, complicated, or even impossible. Before you give cloud providers access to your data, find out what their policies for deleting it in case you want to remove the data completely. Point number 4, cost. Though the cloud can provide computing services at a fraction of the cost of owning them, expenses for cloud services can quickly ramp up with usage. When signing up for a cloud service, check the billing details to learn how services are metered and whether you can set caps or notification when usage goes beyond your desired limit. It also worth researching how billing details are communicated, as the billing methods of some providers are not always easy to understand. Point number 5, company use of data. Cloud service providers may use data to understand customer use of their product, sell or personalize ads, train machine learning algorithms, or even sell customers' data to outside entities. If you have concerns about how your organization's data is used, make sure to find out the service provider's policies regarding to their use of it. Then the last point is loss of user control and visibility. The use of third-party computing resources makes it difficult or impossible for cloud users to have full visibility and control over their computing environments, which can create a variety of technical and trust concerns. Some of these technical concerns can be helped through the use of monitoring and analytic tools, which allow users to stay updated on their infrastructure's performance, allowing users to respond quickly when problems arise. Trust concerns, such as those related to a company's use of personal data, can be addressed by reviewing the company's customer data policies and public forms of analysis about its data practice. Good people, in conclusion, cloud technologies offer a variety of opportunities to businesses, independent developers, researchers, educators, and students. By understanding the difference between models, benefits, and risk offered by the cloud, users can make informed decisions about how to best take advantage of its offering. So, what is a search engine? To answer this question, a search engine is an online tool that is designed to search for websites on the internet based on users' search query. It looks for the result in its own database, sorts them, and makes an ordered list of this result using a unique search algorithm. This list is called search engine result page. If there are several results, they are hierarchical, arranged according to their importance. Good people, given the enormous amount of information available on the internet, search engines are an essential technology today for operation on the internet. Search engines can differ from one to another in their own way of providing answers to the user, but all of them are built on three fundamental pillars or principles, which are crawling, indexing, and ranking. Good people, the actual discovery of new web pages on the internet starts with the process called cloning. Search engines use small programs called web crawlers, sometimes called bots or spider bots, that follow links from already known pages to the new ones that need to be discovered. Each time a web crawler finds a new web pages through a ring, it scans and passes its content for further processing, what we refer to as indexing, and continues in the discovery of new web pages. Once the bots crawl the data, it's time for indexing, which is the process of validating and storing the content from the web pages in the search engine's database called index. It is basically a big library for all the website. Your website has to be indexed in order to be displayed on the search engine results page. Keep in mind that both crawling and indexing are continuous processes that take place over and over again to keep the database fresh. Once the web page is analyzed and saved in the index, it can give a result for a potential search query. The last step includes picking the best result and creating a list of pages that will appear on the result page. Every search engine uses dozens of ranking signals, and most of them are kept as a secret and available to the public. Good people, before looking at examples of search engine. What is search engine algorithm? The search engine algorithm is a term used to define a complex system of several algorithms that evaluates all the indexed pages and determines which of them should appear in the search result for a given query. For example, the Google algorithm uses dozens of factors in several ways. Number one, meaning of the query, which means that understanding what the user means by using the exact words they used. What is the search intent? Number two, page relevance, where the search engine needs to find out whether the page answers the search query. Number three is what we call content quality, where the algorithms determine whether the web pages are excellent source of information based on internal and external factors. Number and quality of backlinks are important factors here. Then the last one, page usability, where search engine consider the quality of web page from the technical standpoint, such as responsiveness, page speed, or security. Then, what are the most popular search engines? To answer this question, although there are hundreds of search engines in the world, only a few of them dominate the overall search engine market and remain popular thanks to their quality and usefulness. The following are three top search engines available. Number one on the list is Google. Google is the biggest and most popular search engine in the world. Owned by its parent company, that's Alphabet, Google dominates the search engine market with over 90% market share worldwide. Number two is Microsoft Bing. Bing is the second largest search engine. It was launched in 2009 and it's owned by Microsoft. Bing in many ways is similar to Google, providing search result types like images, videos, places, maps, or news. Then the last one is Yahoo. Yahoo is just a popular website, email provider, and the third biggest search engine in the world with almost 2% of the overall search engine market share. Thank you so much for watching to this end. See you in the next video, and remember to subscribe. Bye bye.